Okay, because it's fractions, I know steam's coming out of some people's ears already. Rightio, can I have somebody share how they solved it, please? Can you tell us the numbers you got there? So you've got 11 over 4. 4 over 3. Yeah. Yeah. 16. Yeah. Okay, that's good. All right. And I would say that the majority of people in the room worked it out exactly like that. Okay. Somebody else solve it a different way? We'll go for way up the back.
So I said 2 minus 1 is 1.
You said 2 minus 1.
Equals 1.
Yeah, equals 1.
And then I worked on the fractions.
So you knew you were going to be using a bit of the 1, and then you worked on the fractions.
Yep. So I said 3/4 take away 1/3.
Now, you needed to be thinking and reasoning even to do that. What did you need to know in order to even know that you could line those up in that order? If this had been 2 1/3 minus 1 3/4, would you have done that? Like that?
No.
So what did you know already?
I don't know.
The 3/4
Oh,
of
you're all telling her you're such bad teachers. Then give her some space to think. What information did you use that made you think you could just take away 1/3 from 3/4?
Well, I didn't actually, because I jumped to the next stage and said I have to make them equivalent fractions somehow. So
Okay.
I said the relationship between fourths and thirds means that they can be worked as 12ths.
Yeah, okay.
So I said 4's relationship to 12 is 3, so that's 9. And then that one's 4.
Okay. Now,
Yep.
was there any time at all that you thought this might have been a bigger number than that one?
I don't think that occurred to me, no.
When you think of 1/3 and you think of 3/4, which one do you think is larger? Which one do you feel is larger or know is larger?
3/4.
So you knew that already when you lined them up like this?
I don't know whether I thought about it.
Okay. So can I just say then, if you had instead had 2 1/3 take off 1 3/4, you would have done that subtraction.
Yeah.
2 take 1, and then you would have said 1/3 and take away 3/4. Would you have?
No, I probably would have reversed it.
Why?
I don't know.
Okay, that's all right. Don't know. All right.
Probably because I figured I would end up with a minus fraction and then I'd start to panic, put my hand up,
Okay,
say,
that's good. Okay, that's good. So that tells me what I want to know. What does it tell me? Someone out there. What do you think I'm working
People don't
for?
like working with negative numbers.
Sorry?
People don't like working with negative numbers. You can still do it the same way.
But what did it tell me about her knowledge of thirds and quarters?
She can estimate.
Perhaps. Yeah. Okay.
She knows one's bigger than the other.
Yeah. All right. And then you got. There's your 1 up there. You brought that down here, and you finished up with 5/12 to go with it. Yeah.
That's true.
Okay. Somebody work it a different way. So,
I just went right to the common denominator. I just turned the 4 into 12 and 3 into 12. I didn't muck around with the whole numbers because it doesn't matter. A pizza's a pizza, right?
okay.
So I just turned it into 2
So you
9/12 and 1 4/12. So I just took 4/12 away from 9/12, and it's like one step.
So you just kind of saw that bit in your head.
Now, okay, write 2 3/4.
Yeah.
And then the original question, and the next thing I wrote was 2 9/12.
Yeah.
And beside that, I said take away 1 4/12.
Oh yeah. So you just
And
did
then
the
I
jump
just took away
straight
4 from 9 and
Yeah.
1 from 2.
Okay. Yep. All right. Very interesting. Now, I'm going to tell you that theoretically, people, apart from probably disliking fractions, dislike subtraction. That when we're dealing with whole numbers, most people, if I said 97 take away 58, most people in their mind jump to 58 and try and work out how many does it take me to get up to 97. 58, how many am I going to get up to 97? And no, I didn't say all people, I said most people. And the same kind of reasoning can be used here, and some people do that as well. It's interesting for me that everybody so far has done the subtraction version. But what if I said to you, whoops, 1 1/3, and I'm trying to get up to 2 3/4. How much do I have to add? How much do I have to add to here to get to 2? So 2/3 more, and I'll be at 2, and then how much more would I have to add on? Would this get me the same answer? Much quicker? Okay, it's another one of those ones that thinking and reasoning, if all the things we know about whole numbers, we don't necessarily translate it across when we do the stuff with fractions, because automatically we go down this path that probably teaches, the very first version is can I just have a show of hands, who did it the very first version way? Yeah, the majority. And we do that because we default to what we were taught to do, because we're not quite, comfortable with them. But thinking and reasoning, we could have actually perhaps thought along those lines. Even in doing this the first way around, if this number had have turned into, I shouldn't have rubbed that off, but if this had have turned into this, kids who aren't using some kind of thinking and reasoning way, but are following the standard pattern, finish up with enormous numbers that they're playing around with, and you've seen them fall over. They run and get the calculator and finish up doing incredible numbers, not understanding exactly what it is. Whereas using this method, you probably would be able to solve that one quite easily too, by you're never going to be doing more than a little fraction. It's actually not going to involve a whole lot of whole numbers. Okay, thinking and reasoning. Have a look, try it this one. Work that out for me, how you normally would.